What's going on, Rob Mob? Coming at you with another video. Now, this problem should look a little familiar. You've probably seen it in your homework if you've been completing your homework. And it goes a little something like this. A weather station at the top of a mountain reports that the temperature is currently 0 degrees Celsius. And that has been falling at a constant rate of 3 degrees Celsius per hour. If the temperature continues to fall at this rate, what will the temperature be in X amounts of hours? So the biggest step that we have to start off by doing is make sure that we understand what is happening in this problem. So just so I know and I can help visualize it, I know that we are starting at 0 degrees Celsius. This is our start. So what will be happening in 1 hour? In 1 hour, we know that we are reducing our number of degrees by 3 per hour. It is getting 3 degrees colder per hour. So we know that we have the 0 degrees, and then we are minusing 3 degrees. And what we are left with is negative 3 degrees Celsius. What about hour 2? So I'm going to rewrite just for consistency. We know that the first starting position is 0 degrees Celsius. We are minusing 3 degrees, and then we are minusing another 3 degrees Celsius, right? We are going from 0. In the first hour, we are at negative 3, and now we are at negative 3 minus negative 3, which is going to equal a negative 6. Great. What about hour 3? Once again, same process, very simple. We know it's 0 degrees Celsius is our start. Hour 1 is 3 degrees Celsius, negative 3 degrees Celsius, excuse me. Now we're at 3 degrees Celsius again, and then minus 1 more 3 degrees Celsius for 1, 2, 3 hours. What we have here is a 9 degree Celsius. Very straightforward. Now we know we are reducing our number of degrees every hour. Very straightforward. So in our first problem, we know 5 hours. If we want to know how cold it is outside in 5 hours. Now, is there a way that we could simplify these to make it a little simpler for us in the future to solve other problems? So we know that every hour we are being reduced by 3 degrees. So the number of hours times negative 3 degrees Celsius for every hour. That is how much we are being reduced by. So in this situation, we have 1 hour times negative 3 degrees. That is going to give us our answer of negative 3 degrees. Here we have 2 hours times our negative 3 degrees, and that is going to get us negative 6 degrees, right? Negative 3 plus negative 3, 2 groups of negative 3. And finally, we have 3 hours times our negative 3 degrees Celsius. Again, we have 1 hour, 2 hour, 3 hours here, 3 groups of negative 3 that will give us negative 9. So to solve this first problem, we know how many do we have in 5 hours. So we have 5 times our negative 3 degrees Celsius is going to be negative 3 degrees plus negative 3 degrees plus negative 3 plus negative 3 plus negative 3. All of these are, of course, in parentheses and in degrees. And we know negative 3 plus a negative, which is minus negative 3 minus 3 is going to be negative 6. Negative 9, negative 12 equals negative 15 degrees Celsius. And some of you might notice that 5 times negative 3 degrees, we know 5 times 3, that is going to be 15, but a 5 times negative 3, that is going to be negative 15. You'll notice this throughout the problem, a very important concept to understand. So that solves our first problem. Our first problem we know is negative 15 degrees Celsius. What about in half an hour? So now we have our number of hours is 1/2, right? 1/2 times negative 3 degrees Celsius. So we know 1/2 times 3, that is going to equal 1.5. So we know 1/2 times negative 3 is going to equal negative 1.5. negative 1.5 degrees Celsius. Now this is where the problem gets a little more complicated. Now we are going 1 hour back. We are looking at 1 hour ago. What does that mean? Everything else we've been going a little forward, and we know that we are being reduced by 3 degrees every hour. So now we are going backward in time. So let's start at our third hour here. Let's say we are looking at hour 3. At hour 3, we know we are at negative 9 degrees. What happens from going from hour 3 back to hour 2? From hour 3 to hour 2, we now know we are going to be at negative 6 degrees Celsius. So to get from negative 9 degrees Celsius back to negative 6 degrees Celsius, we know that is a positive 3. To get from hour 3 to hour 2, we are increasing by 3 degrees. So we know, let's draw a simple chart. This over here will be time in hours, and this over here will be degrees in Celsius. So we know that at hour 3, our temperature outside is a negative 9 degrees Celsius. We know at hour 2, we are negative 6 degrees Celsius. And to go from here to here, we know that when we reduce by 1 hour, we are increasing by 3 degrees Celsius. So let's keep going. 1 is negative 3 degrees Celsius. And if you're still not sure about this section, all I'm doing is copying the information that we already found here. We know hour 3 is negative 9 degrees, hour 2, negative 6, hour 1 is negative 3. So here's where we are now, also increasing by a positive 3 degrees Celsius. Great, now we've worked our way all the way back to time 0. Time 0, we know from our top, our starting time is 0 degrees Celsius. And to get from negative 3 degrees Celsius to 0 degrees Celsius, we are adding another 3. Great. So now what? Now we are looking for 1 hour ago. 1 hour ago is in the past, and we know that hour 3 is 3 hours later, hour 2, 2 hours later, hour 1, 1 hour later, 0, that is the time right now. Negative 1 hours. That is 1 hour ago. Now we are going backward in time. So what is happening? On this side, we know, well, on this side, for starters, we know that we are reducing by negative 1, right? We're minusing 1 to get from 3 to 2, 2 to 1, 1 to 0, 0 to negative 1. What is happening on this side? Every time we are increasing by 3. So now we are going from 0 plus a 3 degrees Celsius. That is going to leave us at 3 degrees Celsius. So that is our answer for this first problem. A positive, keep in mind it's a positive 3 degrees Celsius. And you can tell that by our charts over here. What about 3 hours ago? So we know negative 2 is going to be another plus 3 on this side. So that's going to be 6 degrees Celsius, and the negative 3 is going to be 9 degrees Celsius because we just keep adding this plus 3 degrees Celsius. So 3 hours away is going to be 9 degrees Celsius. What about this last problem? 4.25 hours ago. So remember up here when we were doing number of hours, 5 hours, times the number of degrees that we are changing. In this case, it is negative 3 degrees Celsius they were changing. It was 5 times negative 3 degrees Celsius. Here, it was 1/2 times negative 3 degrees Celsius. Here, it would be a negative 1 times a negative 3 degrees Celsius. Here we have a negative 1 times a negative 3 degrees Celsius, and that gives us a positive 3 degrees Celsius. Interesting. Okay, what about for this problem down here? Now we have a negative 3, right? Because that is that we are on the negative 3rd hour, 3 hours ago. Negative 3 times a negative 3 degrees Celsius, and that'll give us a 9 degrees Celsius. So let's just do our last problem. A negative 4.25. That is the number of hours that we are currently at. It was 4 hours and 15 minutes ago, so 4 hours, 0.25 of an hour away from now in the opposite direction, times a negative 3 degrees Celsius. So all of these problems, we did a negative 3 times a negative 3, and that got us a positive 9. A negative 1 times a negative 3, that got us a positive 3. So we know that this negative 4.25 times a negative 3 is going to yield us a positive number, the way that we had it in here, right? So if we wanted to make this a little simpler, we could just do 3 times 4.25, and that'll get us a similar answer. So 3 times 4 is 12, plus 3 times 0.25 is 0.75, so our total answer is 12.75 degrees Celsius. Now keep in mind, this is positive because we were positive all down here. We know that every time we go backwards an hour, we are increasing by 3 degrees, not decreasing. But if we're going forward, we are decreasing. So make sure to keep that in mind when you are solving your work. And that's it.